Solve the problem. A 15% solution of alcohol is to be mixed with a 40% solution to get 50 liters of a final mixture that is 30% alcohol. How much of each of the original solutions should be used? We've read the problem carefully for step 1. In step 2, we wish to define our variables. Let's let X represent the number of liters of 15% alcohol solution, and let's let Y represent the number of liters of 40% alcohol solution. Now, in step 3, we'd like to write an equation, but I'm going to organize our information in a table to help me do that. We've let X represent the amount of 15% solution, and let's write that 15% in its decimal form. We've let Y represent the amount of 40% solution, and let's write that in decimal form as well. We're given that in the end we're going to have a total mixture that is 50 liters of a 30% solution. Let's complete this last column, which is the amount of liters of pure alcohol. Well, if this amount X is 15% alcohol, then the amount of pure alcohol is 15% of X, or 15% times X. Same for the 40% solution. We want to find 40% of Y, or 0.40 times Y, to give the amount of pure alcohol there as well. And with our mixture, it's a 30% solution, so the amount of pure alcohol there is 30% of 50. That's 0.3 times 50, or 15. Now we're ready to write our equations. We're given that the total amount of the mixture is 50, and so X plus Y is equal to 50. That gives us one equation. We can also form a second equation using this third column, which is the liters of pure alcohol, because the amount of alcohol coming from X plus the amount of alcohol coming from Y should equal 15. Therefore, 0.15X plus 0.40Y is equal to 15, and that's equation 2. To simplify equation 2 a little bit, I'm going to multiply through by a value of 100 to move those decimal points out of there. So multiplying each term by 100 gives 15X plus 40Y is equal to 1500. I'm going to go ahead and call that equation number 3. Now we're ready to solve this system. And that's step 4, solve your system of equations. I think I'll go ahead and use the elimination method here and eliminate the variable X. So let's multiply equation 1 through by a value of negative 15. Thus that equation becomes a negative 15X minus 15Y is equal to a negative 750. Let's go ahead and call that equation 4, and let's focus our attention on these two equations because we're ready to use the elimination method now. As we add, our X variable cancels. 40 plus a negative 15 is a 25Y. On the right-hand side, 1500 minus 750 is a 750. Dividing now both sides by 25 gives Y is equal to 30. Y is a number of liters of the 40% solution. So we have Y equal 30. Let's solve for X as well. From equation 1, we're given that X plus Y is equal to 50. And so if we substitute that 30 in for Y in equation 1, then X is equal to 20. That 30 plus 20 gives the 50. So X must be 20 liters. Let's go ahead and summarize our answer then and state it very clearly as step number 5. The question is how many liters of each? We need 30 liters of Y, which was the 40% solution. So 30 liters of 40% alcohol solution, and X is 20, we need 20 liters of the 15% alcohol solution. As a last step, let's run a quick check of things. We're given that in equation 1, the total of X and Y should be 50, and indeed it is. And in equation 2, we're given that if we multiply and find 15% of X, or 0.15 times X, plus 0.40 times Y, which was the 30 amount, then we should get an answer of 15. And we do indeed get that because 0.15 times 20 is equal to 3. 0.40 times 30 is 12, and 3 plus 12 does indeed give that 15. And so we want to use 30 liters of the 40% alcohol solution and 20 liters of the 15% alcohol solution.